Today we're going to continue looking at graphing parabolas. So notice that I want us to graph y equals x squared minus 6x plus 4. So remember our steps. The first thing that we're going to want to do is we are going to want to identify A, B, and C. So then we can go ahead and calculate the axis of symmetry. Another reminder, remember here is our very standard parabola equation. Y equals ax squared plus bx plus c. So notice that in this case, the number that's in front of x squared, since I don't see a number that's 1, that's representing a. The number that's in front of x, be careful not to lose any signs. It's a -6. That'd be my b. The value that does not contain an x would be c. So now that I've identified those, I can find my axis of symmetry by plugging in a and b into the following formula. X equals -b over 2a. So I'm going to have my negative sign, and then in parentheses, I'm going to substitute in b, which is -6. That gets divided by 2 times, in parentheses, 1, because that's a. In my numerator, back-to-back negatives means that that 6 is really a positive. 2 times 1 is 2. 6 divided by 2 is 3. So x equals 3 is my axis of symmetry. So notice that that is one of the things that I'm asking for you to identify, AOS, axis of symmetry. So x equals 3. I'm also going to put that 3 in the middle of my table, and then I'm going to pick values that surround 3. So to the left would be smaller numbers like 2 and 1, and then to the right would be bigger numbers like 4 and 5. So remember, those numbers are going to be the first numbers in my new ordered pairs. And to find the second number, we're going to substitute in the x that we just created to every x in our equation. So in this case, there are 2 different spots where we have to substitute in the numbers. So we're going to have y equals, in parentheses, 1 squared minus 6 times 1 plus 4. Now remember, you can plug this into your calculator, but you want to be very careful. Don't lose any parenthesis signs. If I square 1, I get 1. -6 times 1 is -6 plus 4. That would give me -1. So my first ordered pair is 1, -1. So that means with my x and my y axis, I'm going to move 1 to the right and 1 down, and I'm going to plot my point. Then I'm going to substitute 2 in. So we'll have 2 being squared minus 6 times 2 plus 4. Once again, you can plug it into your calculator. 2 squared is 4. -6 times 2 is -12 plus 4. So let's see, what's that going to give me? It looks like 4 minus 12 would be -8 plus 4 would be -4. So 2, -4 is my next ordered pair. So 2 to the right and 4 down, plot my point. When I plug in 3, we'll have 3 squared minus 6 times 3 plus 4. 3 squared is 9. -6 times 3 is -18 plus 4. When we add that together, it looks like we're going to get -5. So 3 to the right, 5 down, plot my point. Plugging in 4, we'll have 4 quantity squared minus 6 times 4 plus 4. Well, 4 squared is 16. -6 times 4 is -24. Then when I add 4, we should get -4. So 4 to the right and 4 down, plot my point. Last number would be 5. So 5 squared minus 6 times 5 plus 4. Well, 5 squared is 25. -6 times 5 is -30 plus 4. Looks like that's going to get me -1. So 5 to the right, down 1. Notice once again, there's a relationship. -1 starts and ends my y's. Notice how -4 is in the middle as far as my second and my fourth terms. Okay, so we should always see that pattern. If we aren't seeing that pattern, that means that we made a mistake somewhere. Notice that I can connect those points. It's forming a U, which is what I wanted. Also notice that my vertex is always going to be the point that's in the middle of the table. So that looks like that is at 3, -5. Remember, we have to draw in our axis of symmetry. So if x equals 3, it should go through that vertex. So notice how, hey, here it's going to go through that vertex, and that is at x equals 3. So I have to have that drawn in. As far as my y-intercept, notice that I don't see it in the graph touching the y-axis, and I also don't see it on my table. But remember, your y-intercept is always 0, c. So I know it's going to be 0, if I go back up, notice how we identified c. C is 4. So 0, 4 is going to be that y-intercept. If I have a minimum or a maximum, notice that because the graph is opening up, that means we have a minimum. And remember, that is always at the ordered pair that is our vertex. So 3, -5. And there's our graph. Let's take a look at another one. Let's graph y equals 2x squared plus 4x minus 1. So once again, our first step, we got to identify the a, the b, and the c. A is in front of x squared, so that's 2. B is in front of the x, so that's 4. And c is the number that's by itself, which is -1. We need a and b, so we can calculate our axis of symmetry by plugging it into the formula x equals -b over 2a. So we'll have the negative sign, then I'll plug in b, which is 4. That's getting divided by 2 times a, which is 2. So in the numerator, a negative times 4 would be -4. In my denominator, 2 times 2 is 4. -4 divided by 4 would be -1. So it looks like x equals -1 is my axis of symmetry. So notice how I can identify that piece down here. And that also means that -1 is going to go in the middle of my table. Now I need to pick values that are surrounding -1. So to the left would be smaller negatives like -2 and -3. To the right would be us heading towards positive numbers like then 0 and 1. Okay, those are the numbers that are going to start off each of my ordered pairs. And now we get to plug those numbers in for all of the x's in order to then find the rest of my answer. So notice that we've got 2 different x values here, so we've got to substitute those numbers in twice. So we'll have y equals 2 times -3 in parentheses squared plus 4 times -3 in parentheses minus 1. Once again, you can type it into your calculator or you can follow order of operations. I'm going to square -3, and that's 9. 9 times 2 would be 18. 4 times -3 is -12, and then I'll subtract 1. So it looks like that's going to give us 5. So I'm going to plot that point. So -3 means I move 3 to the left. +5 means I move up 5, and there is my point. Now I'm going to plug in -2. So we'll have 2 times -2 squared plus 4 times -2 minus 1. Well, -2 squared is 4, times 2 would be 8. 4 times -2 is -8, and then minus 1. Looks like that would give us -1. So -2 means I move 2 to the left. -1 means we move down 1. Okay, now I'm going to plug in -1. So we'll have 2 times -1 squared plus 4 times -1 minus 1. So -1 squared is 1 times 2 is 2. 4 times -1 is -4 minus 1. Looks like that's going to give me -3. So -1 means I move 1 to the left, and then -3 means we move down 3. There's my point. When I plug in 0, we'll have 2 times 0 quantity squared plus 4 times 0 minus 1. Hopefully we notice anything with a 0 will become 0, and then we'll subtract 1. So it looks like 0, -1. So 0 means I don't move left or right. -1 means I move down 1. Last number to plug in would be 1. So 2 times 1 squared plus 4 times 1 minus 1. 1 squared is 1 times 2 is 2. 4 times 1 is 4 minus 1. So that looks like that's going to give us 5. So 1 is to the right, 5 is up. Notice how, once again, I see that there is that similarity with my ordered pairs. I've got my first and my last y's. Oops, I didn't want the whole thing like that. I just wanted the 5. Notice how the 5 is first and the 5 is last. Notice how the -1 is both second and fourth. That should not be a coincidence there. Okay, notice axis of symmetry is x equals -1. So I got to draw that in. So at x equals -1, I've got my nice vertical line. It creates that mirror image with my graph. My vertex is always going to be the ordered pair that's in the middle of my table. So that's at -1, -3. My y-intercept, don't forget, is at 0C. We actually have that in our table. That is at the ordered pair, 0, -1. Because the graph is opening up, we have a minimum because we have the lowest point possible, which once again is my vertex at -1, -3.